Alrighty, let's go over these. So with all these problems, you should probably do it in the following steps, or at least sort of in your brain, you should go, all right, number one, what type of angle pair is it? Number two, what's the relationship for that angle pair when the lines are parallel? Number three, what's the equation? So if you look here, we've got, for number one, we've got this angle right here, this angle right here. So this angle and then this angle. Remember, we make a z, therefore we're talking about alternate interior. Alternate interior angles are congruent. That means we set them equal to each other. So again, y'all saw that's the order of the way you should think about it. Step one, what are they? Alternate interior angles. Step two, what do we know about our alternate interior angles? They're congruent to each other for parallel lines. So step three, what's my equation? Well, they're congruent, so the measurements are equal. So we write down, and now we solve. Remember, if you've got an x on both sides, that should be your first priority, just so that you get some direction here. So I'm going to move the x over to the left. I'm going to subtract 4x. So it gives me, that leaves me with a two-step equation. Now I either add or subtract, and then I either multiply or divide. So let me add 12 to cancel out the 12 over here. Let me divide by 2 to cancel out the 2 here. And I get x equals 12. And again, if you're not sure that what you've done is right, you can always plug it back in and make sure. 6 times 12 minus 12. Well, 6 times 12 is 72. Minus 12 is 60. So this angle is 60 degrees. Let's make sure that we get the same thing over here. 4 times 12 plus 12. 4 times 12 is 48. 48 plus 12 is also 60. So 60 degrees, right? So we did it. Hooray. All right. Let's do the next one. I'm gonna clear all this out now. So one thing to notice here, there's a bunch of extra lines on the rest of these. Don't be afraid of them. Extra lines can just be ignored, right? This whole line right here, this thing, has literally nothing to do with the problem, right? And it's okay for you to say, I don't want this here, and just ignore it or erase it or draw your picture without it. So first thing, once again, step one, what type of angle pair are we working with? This angle and that angle, these are corresponding, right? That was step one. What do we know about corresponding angles? They're congruent. So I know that these are equal. Step three, what's the equation? All right, this red box means 90 degrees. So x plus 100 equals 90. So I subtract and I get x equals negative 10 for my answer. And again, if you want to check to make sure that you did it right, plug it in. Negative 10 plus 100, that had better be 90, right? Hey, it works. Don't be afraid of these problems. If you break it down and think it out, it'll get easier, and then you'll have to do less thinking. Let's do Let's skip this one. We'll come back to it and we'll do this one first. So take a look at what we have here. This middle line, not important. We don't care about it. All we care about is the angle that's right here and the angle that's right here, yeah? Well, these are same side interior as each other, so they add up to 180. So I'm going to write the equation. Part plus part equals whole. First part, second part, whole thing, right? Part plus part equals whole. So now we've got our equation. Let us combine like terms. 7x and 7x makes 14x. 6 and 20 makes 26. Subtract. I get 14x equals 154. Which sounds like it goes into 14. Let me divide. Yeah, that's 14 times 11 is 154. Hey. So x is 11. And once again, if you're concerned, hey, I don't know that this adds up to 180, plug it in. 7 times 11 plus 6 is 83. 7 times 11 plus 20 is 97. 83 and 97 better make 180, right? Okay, last one. This one, the problem is that the spare line in here sort of really gets to people. Like this spare line that's going diagonally this way, it's unnecessary, right? We don't need it. We don't care about it. But it's right there in the thick of things, so it can be confusing. So again, it really does help if you highlight the stuff that matters. Maybe do it better than me, but that's okay. But like once you do it, make sure that my tablet isn't all sideways so that I can actually draw a straight line. There we go. See, these green lines are the lines that are supposed to be parallel. The red line is the transversal that cuts through. And so we can see better now that these two angles are alternate exterior angles, right? They're both on the outside of the sandwich. One's on the left side of the right line, one's on the right side of the red line, right? Alternate interior angles are congruent, so we can make our equation that 5x plus 3 equals 48, right? This equals that. So let's do our math here. And divide. X equals 9. And once again, all you have to do is plug it in to make sure that they're the same. 5 times 9 is 45 plus 3 is 48. That's all. So these are the things that I expect that you are able to do. You know, along with being able to actually reason it out, you should absolutely 100% be able to do problems like this. They're going to come up and they're not going away. That is a promise from me to you. All right, so what are we going to be talking about today? So we talked about parallel lines. Now we're going to be able to throw perpendicular lines in there. And what does perpendicular mean? Perpendicular lines. We can't talk about angles that are perpendicular. We can't talk about just random things that are perpendicular to each other. Perpendicular means that they intersect at a right angle. So two lines can be perpendicular if they cross and make 90 degrees in the middle. That is what perpendicular means. So let's talk about the stuff that's going to be coming up here with the perpendicular. Let me make these bigger for us, just so that they're easier to see. Is this going to be too big? It's probably going to be too big. Yeah, look what I've done. Oh well. I tried. So these theorems, and they're going to be in your homework. You're going to talk through them. Basically, say that if you've got different combinations of parallel lines and perpendicular lines, you can draw a conclusion from what's there to what the pieces that didn't get any sort of concentration. So, like they're saying, if line A and line B are parallel, if line B and line C are parallel, well, what does that mean, therefore, about A and C? And if we look here, it's pretty easy to see that line A and line C are about to be parallel themselves, right? So the way that it works, the way that they're going to do this is they're going to like have a situation that looks sort of like this, right? And they're going to say, all right, well, with the lines that I know are parallel, I can make congruent angles there. With the other lines that are parallel, I can make congruent angles there, and then you'll have three congruent angles. You'll be able to use the transitive property to connect them. Now, with these other two, the transitive property doesn't work so well, right? You have to be able to sort of do a little bit of extra thinking, because here for 3-9, they're telling you if you know that two lines are perpendicular to the same line, what are they to each other? M is perpendicular to the cross T here. N is perpendicular to the cross here. Well, what about M and N themselves? How are they to each other? And if you look, they look like they're parallel. And the fact that they've got these right angles here tell you that those angles are congruent, and those are corresponding angles, right? Corresponding angles congruent means that the lines are parallel. With this last one, they're going to sort of do the same idea. They're telling you about how N and L are related to each other. They're telling you about how L and M are related to each other. But they don't ever say anything about N and M. Well, what can we do? If you know that N is perpendicular to L, and L is parallel to some other line, then M is going to have to be perpendicular to that line. And again, it's going to go through. We're going to use the fact that these two lines are parallel to transfer this right angle over here, showing us that N and M therefore have to be perpendicular. Now, what I'm telling you is that this stuff is very visual stuff. You cannot do this all in your brain without it being like ridiculous. Honestly, I absolutely would, at this very moment, if you haven't already done so, make sure you've got a sheet of paper so you can draw. When I do the problems I'm about to do with you, I'm going to draw it on the screen because I can't do it in my head. I can't, and I won't, because I want to make life easy for myself, not difficult. So I want to know about A and D. How do they relate to each other? Well, let me figure it out. I've got, there we go. So what do I have here? I have A and B are parallel, so let me draw two parallel lines. There's A, there's B. Now, I know B and C are parallel. So let me draw another line that's parallel to B, right? I'll do that over here. And we'll call that line C. So now I know that C is perpendicular to D. So let me draw a line that is perpendicular to D. So if this is true, what I want to know is how A and D are related to each other. Are they parallel to each other or are they perpendicular to each other? Do they never touch or do they cross at a right angle? What's the answer? Anybody tell me? Line A and line D, how are they related to each other? It's a right angle. That's exactly right. They meet at a right angle, so A and D are perpendicular. Now, when we when we write this out, I mean, you can literally write it down in words, but there's a symbol that we use for perpendicular. And it's this upside down T, like this. So what we would say is A is perpendicular to D. This little symbol here. You can use that interchangeably with the word perpendicular, just like you can use this symbol, the two vertical lines, interchangeably with the word parallel. All right? I'm going to put 2 minutes on the clock. You're going to tell me about this situation. I want to know how A and D relate here. And again, take the time to write it out. If you don't write it out, it's going to be so difficult. Don't do that to yourself. Be kind to yourself. Draw a picture. All right. So, once again, as we're doing this, it behooves us to draw a picture. So, we've got A is perpendicular to B. Let me draw A and B so that they're perpendicular to each other. And labels so that you don't get lost, right? Here's A. Here's B. Now, what do we know about B and C? Our new line that we're going to draw, C, is parallel to B. It doesn't matter where we draw it. I'm just going to draw it over here. So we'll call that C, right? And then what do we do next? Well, C is perpendicular to D. Well, again, let me draw C. Let me draw D so that it crosses C at a right angle. So I've got this, right? Oop. No, I don't. Let me get the other one. There we go. Okay. Notice how by drawing a picture, this is all the information, right? A is perpendicular to B. B is parallel to C. C is perpendicular to D. And now what do I want to know? I want to know about A and D. So what is A compared to D? Parallel or perpendicular? Parallel. Very good. Yeah, see? They're going the same way. And to tell you the truth, like you can go through and you can really sort of rationalize this to the nth degree. You can be like, okay, well, I know A and B are perpendicular, so angle 1 is a right angle. Since we have parallel lines here, corresponding angles are congruent, so I know angle 2 is a right angle. Since angle 2 is a right angle and angle 3 over here is a right angle, They're the same and they're corresponding angles. Corresponding angles are congruent. That means that line A has to be parallel to line D by the converse of the corresponding angles theorem, right? Yeah. So, hey, listen, it's simple once you draw it out. If you draw it out, it will be so much simpler than if you try and do it in your brain. If you do it in your brain, you will get an aneurysm. Your nose and ears will all start bleeding because you're thinking too hard. Don't do that. There's no reason to do that. Give yourself the space to let your brain not overheat. It's okay. I am okay with you doing things in an easy way so that you don't have to struggle. I'm okay with that.